And we've seen this graph before, right? So some of these are one-sided limits, so I'm just going to kind of jump around a little bit, and then we're going to move on. I would recommend that you go back to this. I mean, it's just a combination of points, one-sided limits, two-sided limits, and so on. So we already evaluated, let's look here. So if I want to evaluate the limit as x approaches 0, does the limit exist? The limit as x approaches 0, I'm looking at E. Does the limit exist? Yes, the limit exists because as I approach from the left and from the right, I get the same value. So what's its answer? It is 1. Okay? But what about f of 0? Yeah, this one does not exist. It's a hole. Make sense? So a point doesn't necessarily have to exist for the limit to exist. So what about the limit as x approaches 2? It does not exist. Okay, but what about f of 2? It is 3. Nice. Okay? Questions on this? Okay, I mean, you guys have evaluated some of these. We did this one and we did this one on the previous page. So there's no point in us doing it again. Mitchell, are you good?
Yeah, wait, why? Sorry, why is it 3?
Why is it 3? Can someone tell me why f of 2 is 3? Robbie?
Because the bottom part of the parametric, the bottom part is open, but the top part is closed. It's a closed hole. That's what it's evaluated.
That's right. This is an open, this is a hole in the function somewhere, or that piecewise function might say for any value less of x less than 2. It's okay. We have to review this. We got to get back in the swing of things, right? Everybody good? Yep. Okay, let's move forward here. I know that some of us, including myself, do not like these, but determine if the statement is sometimes, always, or never true, and then draw a graph to explain your answers. Okay, so we need to think about conceptually what is happening with the definition of a limit. So it says if the limit as x approaches 2 of f of x does not exist, okay, so the limit doesn't exist. So a couple things have to be happening here. Then the limit as x approaches 2 from the right doesn't exist. So is this sometimes, always, or never true? Sometimes. Sometimes true. Okay. So to make this true, okay, we would have, let's say, a graph like this, and we're saying that the limit won't exist, then the limit from the right doesn't exist. So could we say if this is 1, 2, maybe the graph goes up like this. This is the limit from the right. And then the limit from the left could be anything, right? It could go like this. I mean, I just made it up. But I mean, it could be almost anything, but what we're saying is here the limit doesn't exist. Or there could be no graph at all. Because in order for you to evaluate the limit as x approaches 2, you got to look to see what's happening from the left and from the right. What if there is nothing from the right? Can you make that determination? You cannot. We can only determine the limit from the left. Does everybody understand this? So this is the true part. I could make it false, which gives me the sometimes. So it would look something like this. So if this is 1, 2, and I put, I don't know, like this, and then the graph looks something like this. Doesn't the limit from the right exist and from the left, but the limit overall does not exist because they're different values? Again, I just made up this. I just made it up. So here, in order to say sometimes true, this makes it true, but this is what creates a false statement, so that's why it's sometimes. Everybody good? If you had to sketch a graph. Robbie, I'm sorry, you have a question?
Oh, no.
Stretching. Okay. Stretching is good. I'm fine with that. Okay. Any other questions about A? Okay, let's take a look at B. If the limit as x approaches 2 from the right does not exist, then the limit as x approaches 2 overall of f of x does not exist. Is that a true? Sometimes, always true. Always. And this is based on the definition. So if the limit from the right doesn't exist, well, we talked about it. It's right here. So if you had to draw the graph, it would be like this. So you could say something like 1, 2, You have no graph over here, and then maybe you come up like this. I don't know. I just made it up. Okay, we're going to talk about limits at infinity, but another example might be if you have something like this. If you have a vertical asymptote and the graph from the right goes like this, we saw it on another function where you're approaching from the right and the limit just either continues up or it could continue down like this. So another way we could say that is that the limit doesn't exist in a unique way. The graph is heading towards either positive or negative infinity. Questions? Everybody doing okay? How's the first day so far?
Good.
Like the first real day. Good? Awesome. Okay. All right, so let's talk about limits at infinity. As I alluded to, we would be discussing here. Let's talk about a little bit of our foundation. So limits at infinity. So sometimes the limit as x approaches a of f of x does not exist, okay, because x is assigned values that approach a, and the corresponding function will either, the values will grow larger without bound, or they will become smaller without bound. Okay, and in this case, we're going to say the following. The limit as x approaches a, if we are increasing without bound, the limit will approach positive infinity. Okay, so I'm going to tell you something about my infinities. I cannot do a sideways 8. And besides, when I draw my 8 anyway, I do 2 circles. That's just how I've always done it. I don't do this thing. See, I can't even do an 8 like that. I've always done this. I don't know why. I'm a weirdo. So sideways is even, if I can't even do it upright, I can't even do it sideways. Do your best. But remember, it needs to be connected. Okay, this is not infinity. These are 2 eyeballs or something. I have no idea. Okay? So we want to remember also, too, that the limit as x approaches a of f of x being equal to infinity still means that the limit doesn't exist. It just fails to exist in a very specific or special way. Okay, so if I say the limit as x approaches 2 is going to infinity, and this is an open-ended question, and George says it doesn't exist, we are both correct. Because what you're saying is, when I say the limit as x approaches 2 is 5, you're saying that the graph is going to stop there. Okay, whether it's coming from both directions or I'm talking about a one-sided limit. But what we're saying when we say infinity or does not exist is that there is no limit to this function. There's no limit to it. Nothing's holding it back. It's just going to keep going. Okay? Questions? Okay, so let's take a look. This here too. Forgot to highlight. All right. So it could be either positive or negative infinity. So what we want to look at here is the limit as x approaches negative 2 from the left. So here is negative 2 from the left. Where is that graph going? Positive infinity. Okay? And part of the reason that I don't want to say does not exist is because if you look at the next 2 questions, I want to know about the limit overall. So if the end behavior is identical, then I'm going to give a final answer of either positive or negative infinity. If they are different, like this, then you would say does not exist. So you really need to be conscious about how you're answering. So then the limit here as x approaches negative 2 from the right is also positive infinity. So since these 2 one-sided limits are the same, the overall limit would be the same value, which is infinity. Okay? Yes?
So could you have like a limit for like as x approaches negative 2 from the positive side that's like 3 or
Sure.
something like that?
Yep. See if you look at this one. So the limit as x is approaching 3 from the right is 0, but then from the left it's infinity. Yeah, so here you can actually, well, here you go. So I can ask you questions 1 and 2-sided questions, but it could be all in one question. You're just looking at the graph. Okay, so it's a matter of interpreting how you're going to answer that. Okay, does anyone have any questions? I'm going to let you guys do these next few examples. Everybody's okay? All right, go ahead. Okay, let's review these quickly. All right, what's f of negative 2? F of negative 2. dne, that's right. E. Negative infinity. F. Okay, so because these are different, what's this going to be? dne is correct. What about f of 0? That also does not exist because there's no point there. Okay, so then the limit as x approaches 3 from the left. Perfect. Okay, what about from the right? Not the same, so what is this? What about f of 3? Awesome. Questions? You guys are killing it. Everybody's good? Yeah? Okay. All right, let's take a breath here. Yep. This is the last piece. So remember when I told you guys you would have time? Yeah, crazy, right? Okay, it's not always going to be this much time, but had you been in a classroom last year, I think pre-calc honors, you would have done something like this. Your teacher may have done it.
Oh, yes. I remember these.
I think I may have done, I don't even remember. These are not my favorite, but we do have to do them. They are not eliminating anything this year. So here we go. It says sketch a possible graph for the function f of x with the specified properties. Now what you need to understand is today we're going to be doing this together. So our answers are going to be the same, but if you do this on your own, it is possible that your answer or your graph might look different from your neighbor's. Make sense? Okay, so what we want to look at here is what each piece is. Here we have f of negative 1 is equal to 0, f of 0 is equal to 1. What is that? Yeah, these are points. Okay? So what this means is we have negative 1, 0, and 0, 1. So I am definitely going to plot these. So I've got negative 1, 0, and I've got 0, 1. Okay, those are easy. So we're done with that. Most likely we will not have to go back and check. Do you agree? Okay, so now what we need to look at is these pieces and make sure we get everything good. So we've got the limit as x approaches negative 1 from the left of this given function, whatever we're drawing, is equal to negative 2. So essentially what I have is a point negative 1, negative 2, okay, that we're looking at. Okay, so when I go to negative 1, negative 2, I need to think about this for just a second. I do know that this is a limit, so I'm going to have to draw part of my graph. But am I going to make this an open or a closed circle?
Open.
Why?
Because the other one was...
Yeah, this is already given. It is a point, and we know definitively that it is a point. So here I need to make this an open circle. I'm exaggerating so you can see it. And as I approach from the left, that means my graph needs to be coming from this side. Folks, does it really matter? I mean, could it come this way, this way, this way? It doesn't matter. So I'm just going to draw it like this. Does not matter. Okay, if we all do the same thing, it's going to look the same. It's fine. These are your notes. Okay, so I did this, but I'm going to go back to it, so I'm just going to give it a little check. Then we've got the limit as x approaches negative 1 from the right is equal to 2. So again, we have another point, negative 1, positive 2. So I go to negative 1, positive 2. Again, we already made this decision. This has to be an open circle, right? So there's my open circle. I always try to exaggerate so I can. So then here's my question. I need to approach from this side. So this is from the right. But I also need this as part of my graph. Can I use this? Of course I can. Does it matter what the graph is going to look like? No, but I don't want to draw anything yet. I have a tail here. I'll fix it in a few minutes because I don't know what's going to happen with the rest of it. I still have some other stuff to deal with. So I would wait before you draw anything. So I have a tail just to kind of remind myself, go back. So I'm going to check this off. Okay, now I want to go through what it means when you have infinities here, or if you have infinities here. So in general, I'm going to make some notes down here. I've got the limit as x is approaching some number, whether it's positive or negative and from the left and to the right of a given function, is equal to either positive or negative infinity. This is just in general, like if we were taking notes. What this means here is that you have, think about it, if x is approaching some given value from the left or from the right, and you're going to either positive or negative infinity, what do you think is forcing that graph to do that? An asymptote. Nice. And more specifically, what kind? Nice. So whenever you have a scenario like this, where you're equal to positive or negative infinity, you're going to have a vertical asymptote. Does that make sense graphically, like what's happening? Okay. So then let's switch this. If we have the limit as x is approaching either positive or negative infinity, okay, of f of x, and it's equal to some number. So as x is approaching positive or I got to see if I can do this with my hands. I don't know if I can. Positive or negative infinity. So it's going to go like that, but it's approaching some number. What? Yeah, I have horizontal asymptotes. So I would kind of consider this important general information. So when I'm looking here, I know what I've got. So I have, in this case, this scenario, so these are going to be vertical asymptotes of some kind. Does that make sense? So what I'm looking at here is, I'm approaching 3 from the left and from the right. So at x equals 3, we have a vertical asymptote. I'm making a note to myself because now I'm going to go to where x is 3 and throw a vertical asymptote there with a dotted line. We're going to go back through and check all this stuff in just a second. Excuse me. But what this says is the limit as x is approaching 3 from the right. So here's 3 coming from the right. Whatever my graph looks like, it's going to go up or down. It is going to go down. So could I do this because I have no points over here? I have nothing over here, so I have free reign. You can make it a spaghetti graph, like whatever you want. On this side, I've got stuff, so I want to be constructive with my graph. As I approach from the right, from the left, I'm headed towards positive infinity. Well, I just asked you about this. This little tail here, I could take this and include this point and then swing this up and head towards positive infinity. Okay, do you have to? No, this could actually go over here and this could just be a point, as long as you have that point on there. So I'm going to use it, because it's right here, and just skirt my graph up that way. Okay, so I think I've used every piece, but I want to go back and check. The points I'm 100% sure on, so I'm going to skip those. Here, I need to evaluate the limit as x approaches -1 from the left, and make sure I'm approaching -2. Here's my graph. Here's -1 coming from the left. I'm at -2. Definitely done. Check. The limit as x approaches -1 from the right is equal to 2. Now, we already double-checked these points, so this is also good. Then we've got the limit as x approaches 3 from the left. 3 from the left. I want to go to positive infinity. Here's my graph. Am I doing that? I sure am. And then 3 from the right is negative infinity. So this is a big double check. Okay. These take a lot of practice, and we need to be patient. Again, I admitted at the very beginning, not my favorite thing, but it takes practice. Okay, questions? Are you sure?